My answers to the first two are up there. Notice that here, square root of 14 squared, square root of 3 squared, this gives me 14 and 3, which ends up being greater than 16, which is on the other side, 4 squared. That's a cube. Here, notice that 4 rad 5 becomes 16 squaring 4 times 5. This just gets rid of my radical there. Gives me a right triangle. I'll give you some time to finish up the bottom too. Day 1. I'm having a hard time breathing today with a mask on. Does that ever happen to you?
All the time.
I like need an inhaler.
Yeah.
It's hard to talk, like teach a lesson with a mask on.
I know some masks when you breathe, it like dries out your eyes.
A little bit, yeah. I just like, normally I'm okay, but today in particular, I'm not feeling it.
Cam's struggling to see right now. I don't know.
I guess so. Should get a note back from them. Okay, this is in the Unit 8 packet. So far in Unit 8, we did a review of radicals because we need them for this unit. Then we talked about the Pythagorean theorem. And like basically up until now in a math class, if you had a right triangle and you had to solve something, you were using the Pythagorean theorem. But I can only use the Pythagorean theorem if I have 2 of my 3 sides. So if I only have a single side, I can no longer use the Pythagorean theorem. I can use other ways to solve, which is where we're going for this unit. One way that we can solve is if we happen to have a special right triangle. So one type of special right triangle is 45, 45, 90 triangles, which means the angles are 45 degrees, and 90 degrees. To kind of discover what happens with these special triangles, they're always going to be the same, because if our angles are the same, our sides are going to have the same relationship. I have a square here. I don't know the length of the sides, but I'm going to call the length x. Because it's a square, it's x all the way around, right? Same length all the way around. And in our squares, we've already done this unit. We know we have 90-degree angles. We know all of our sides are the same. And we also know that on our squares that when we draw on a diagonal, that it bisects the angles. So it would cut these angles into 45-degree angles. So by drawing a single diagonal across my square, we're not going to draw both diagonals, just one, I will create 2 45, 45, 90 triangles. So I'm going to look at just this 45, 45, 90. Okay, so here's my right triangle. And we know, so things we know now would be a squared plus b squared equals c squared, whether this has to be the hypotenuse. Okay, we know that. And this has to be my legs. These x's, are they legs or a hypotenuse? These are the legs. This is my hypotenuse, right? So if I substitute in what I have currently, I could say that x squared plus x squared equals, and we don't know, we don't have a variable here, but equals that hypotenuse squared. Or, these are like terms, 2x squared would equal the hypotenuse squared. So if I just wanted to figure out what the length of that diagonal is, I could take the square root here, which is going to get rid of that being squared. So c equals the square root of 2x squared. So let's look at that. How does that simplify? Well, I can't simplify the square root of 2, but I can simplify the square root of x squared. What's going to happen if I have the square root of x squared? It's just, yeah, it's just x, right? Those are going to undo each other. And it gives me x and a rad 2. When we do write it as x rad 2, not rad 2x. Okay, so the square root of 2x squared, I can evaluate the square root of x squared. That's just an x. I can't evaluate the square root of 2. It's not a perfect square, and I can't simplify it at all, so I leave it. My hypotenuse on these special rights, I can always find by taking the side and multiplying by the square root of 2. So it's a pattern that's consistent, that if I know one of these, I can find the other because they're all using whatever x is, I can plug it in to find the other side. So what we need to be able to do is move from any single side in these triangles to the other two sides. If I'm given a hypotenuse, so let me draw on a 45, 45, 90. If I'm given that the hypotenuse is 3 rad 2, let me redraw what we had up above in my half a square. We had x, x, x rad 2. X, x, x rad 2. If my hypotenuse is 3 rad 2, what are each of my legs? 3 rad 2. This is x rad 2. So what's x? 3. Well, what are my legs? They're just 3. They're just going to be what x is. 3 and 3. So to go, how do you get, oh shoot, I did it backwards. How do you get from a hypotenuse to a leg? Let's flip flop these, or you can erase it and redraw it. This should be here. I got excited. From the hypotenuse to a leg, that's this diagram. Okay. If I know the hypotenuse and I want to find a leg, then I just divide out the square root of 2. Okay. If the hypotenuse is 3 rad 2, then the leg is just 3. Okay, that diagram should be for the other one side. How do you get from the leg to the hypotenuse? So let me give you a diagram for that. If I knew the leg was 4, well then I know the other leg is 4. Let me make that a 45, 45, 90. And what would my hypotenuse be? X, x, x rad 2. What would this one be? Plug in x. 4 rad 2. To get from the leg to the hypotenuse, I multiply by rad 2. It's all about substitution. It's a game of substitution. I know one side. From that, I need to go and find the other side. It's going to make more sense, hopefully, when we start to do it. Okay, so flip this page when you're ready. We're not starting with the first, well, maybe we are. Sorry, I think I changed the order this year. You can start with the first one. Okay, I did. So use the rule of 45, 45, 90 triangles to find the missing side. So at the top here, I'm going to draw on what we are going to use. We're going to use this consistently. X, x, x rad 2. So anytime that I see a triangle and it is only giving me one side, then I know that I can't use the Pythagorean theorem. Hi. Maybe sit where Rohan is. It's the first section. Okay. Okay. Okay, so here's my 45, 45, 90 kind of rule, set rule. And again, if I only have one side, I can't use the Pythagorean theorem. I need to either use trigonometry, which we haven't learned yet, and we'll learn at the end of this unit, or special rates. I know that I can use a special rate if it tells me the angle. So you have to have identified to you that it's a 45, 45, 90. I can't just use this willy-nilly on any triangle that only has one side. But if it's this special triangle, then I can. So this is how I kind of work this. So first thing I'm going to do, we want to fill in these missing sides, both sides. We want to solve the triangle. I'm going to, around the outside, draw on what the rule is, x, x, x rad 2. And I do that for any special rate. Just kind of write in what's the relationship. And then I decide, okay, well, the side I have is x. So I know x equals 5 in terms of my pattern. I'm just going to go in, and anywhere I see x on the other sides, I'm going to plug in 5. So this side is 5 because it's just x, and this side is 5 rad 2. And all I'm doing is taking x that I know because it was given to me, and I'm plugging it in for my remaining sides. Okay. Now the 45, 45, 90 ones are easier because if I'm given either of my legs, I'm just like good to go. I can just plug in because the legs are x. If I'm not given, so like on 2, a leg, I know it's x, x, x rad 2. If I'm not given a leg, then I need to make sure I solve for x first. So let's write that. Make sure you solve for x first, and then I just plug into the other sides. Give you a chance to write that down. So on the second one, I'm not given x. I'm given the side that's x rad 2. So I know the side that's x rad 2 is 7 rad 2. If x rad 2 equals 7 rad 2, I get x by dividing by rad 2. And what does x equal? 7. So I've solved for x. Now I'm just plugging that in. So if x is 7, 7, 7. Those two sides are just x. So my missing sides are 7 and 7. Not always quite as simple as that. Let's do, I decided which one I'm going to do first. Let's do 4 first. Might do come back to 3 at the end. Didn't give me an angle here. We're going to just say these are 45, 45, 90s. X, X, so do you need help finding this page? We're in unit 8, right there. That's number 3. So I don't need to solve for x because I already know what x is. X is 2 rad 3. Okay, I'm going to take this and plug it into the other side. So here, I just get 2 rad 3 again. That side's also x. Here, let me do some work. I get x times rad 2. That's what I have here, x times rad 2. So plugging in what x is, which is x is 2 rad 3, I get 2 rad 3 times rad 2. And we're going to simplify that to get the length of my side. I can only multiply numbers that are outside rads with other numbers that are outside rads. And I can only multiply inside numbers in my radical with other inside numbers. So I can multiply the 3 and the 2 together, and it would give me 2 rad 6. This side is 2 rad 6. When I take x and I multiply by rad 2, that's what I get. Let's look at 5. Similar things going to happen on 5. So if I label the outside, I have x rad 2. Remembering that x rad 2 always is the hypotenuse length. So I know x is rad 5 over 5. I know that. And I'm just going to plug it in. And this isn't like I'm not solving. I'm just kind of identifying that this is separate. I'm just saying this is what x is. Now I will substitute it in around. So this side is rad 5 over 5 because it's just x. So I'm just plugging x in. The other side is x times rad 2, and x is rad 5 over 5. You see that I'm just doing substitution? Now, when I have a fraction times this rad 2 or times a single radical, this radical's over 1. So really that's just in the numerator. So my numerator would become the square root of 10, and the denominator is 1 times 5, 5. I can't reduce that. That's not a 2 or a rad 2. Okay, the 10 is inside a radical, the 5 is not. So I can't reduce that. If they were both not in a rad or they both were in a rad, I could. Okay, but 1 out, 1 in, can't do anything with that. This is just rad 10 over 5. That's what this side simplifies down to. On the next example, x rad 2. The side I'm given is my x side, so I know x equals this. I'm going to plug x into my other two sides. So my other leg is also going to be 7 rad 2 over 2. My legs match in these 45, 45, 90s. Here, I need to do some math. X times rad 2. And x is 7 rad 2 over 2. So this is like rad 2 over 1. Multiplying my numerator, what is that going to give me? 7 and 2, or let's write it as the square root of 4 for a minute, over 2 times 1, which is 2. So what happens here is I can't multiply the 7 by anything because it's outside the rad, and there's nothing else outside the rad. But the 2's I can multiply together because they're both inside a rad. And 2 times 2 gives me 4, which is nice because 4 is a perfect square. So this is really 7 times 2 over 2. And what happens when I have a number over itself? It's just going to cancel. Or I would have had 14 divided by 2, which is 7. Okay, this side is 7. And I only get there by taking x and plugging x in to the expression x rad 2. Why don't you try just 7 on your own? Give you a moment to look at 7 on your own. Mute this for just a minute. I'll put this back up in a minute. on 7, which side am I given? An x or an x rad 2 side? An x side. So x rad 2. I know that x is 3 rad 2, which means my other side is also 3 rad 2. And this side is going to be 3 rad 2 times rad 2, or that x value times rad 2. Rad 2 times rad 2 is rad 4, or just 2. And what is my hypotenuse end up being? 6. Good. Now look at 8. I'll give you a minute if you haven't gotten through 8 yet. Look at 8, see if you can fill in your other 2 sides. Well, I'll do this in a minute. I have hard copies of the take-home test if you want it. They have to be stapled though. You want one? Anyone else want a hard copy of that? Actually, maybe we'll do something real quick, and then I'm going to give you some time because you have this due tomorrow, and you have some special ed homework. So if you haven't started this yet, you can have some time for it. You want one? Hard copy?
I want to.
You sure? Oh, right, I gave you a hard copy already. Hard copy? Yeah. Yeah, and you want the paper one. Okay, so on this number 8, we're again given x, so my other side is going to match, right? But then here, I need to plug in x, so 3 rad 2 over 2, and multiply it by rad 2, which looks like this. Gives me 3 rad 4 over 2, which the square root of 4 is just 2. And what does this simplify to for your final answer for that side? 3. Yep. This side is 3. Okay. I kept the hardest one for last, so we got to go back and look at 3. So this kind of stinks when I have a rad in my side, so I got to do some kind of quick math here to figure out this side. The kind of worst case scenario on these 45, 90s is you're given the hypotenuse, and the hypotenuse isn't in like an easy format. So this is x rad 2. So the side that I am given, so I'm just going to push this up a little bit. Remember, if we're not given the side that's x, I'm going to solve for x first, and then I'll plug it in. So right now, I know that x rad 2, the side that x rad 2 is 16. I need to solve for x, which means I need to divide by rad 2. Which when we did that on number 2, it was easy because the rad 2's just canceled on both sides. But here, it's not quite so easy, and this is why we started with radicals review this unit. So I get x equals 16 over rad 2. This is improper. We never leave a radical in the denominator of a fraction. So when I'm solving for x and this happens, I need to do what's called rationalizing the denominator, which we do by multiplying by rad 2 over rad 2, which would give me 16 rad 2 in the numerator, 16 times rad 2. And then the denominator, it's going to give me rad 2 times rad 2, which is 2. Yeah, so it's the square root of 4. And it's going to simplify to just 2 because 4 is a perfect square. That will always happen. So rationalizing the denominator means you're going to get rid of the rad in your denominator by doing this, by multiplying by the radical you have here. Rad 2 times rad 2 is regular 2. or the square root of 4, which is regular too. And then if we can reduce these outer numbers not inside the rads, we do. So in this case, our final answer, oops, sorry, not for that side, is that x equals 8 rad 2. And I plug that in. Okay, so if I'm given the x rad 2 sides, sometimes it's really a mess to try to get x and then plug that in for your other sides. Okay. So what I would like to do before I kind of just let you go, so you have your test and some homework on this, is I have 4 problems that I have pulled up for you to do just kind of a quick check. So it's like 8 minutes or so of work. I can get some paper next door if you don't have blank paper. So I'm going to put up 4 problems here. If I can find it. That are 45, 45, 90s. I will reveal. Why is this lighting up? Let me just see if I can do this. There we go. Okay, can you see those okay? I don't really think I can make them much bigger, but. Okay, so figure out what side do you have in terms of the x rad 2. I'll get some blank paper in case anyone needs it. Find the other 2 missing sides. Ignore this, by the way. Like when they put variables in, I just ignore it. Like, I'm really just thinking about x rad 2. And then I find the sides, and if those happen to correspond to x and y or a and b, fine. But I'm not really thinking about those. Who needs blank paper? Want some blank paper? Tiny over here. Let me. I can read that maybe. From Hannah and Rivers angle, it's very hard to see that. Triangle. Not sure how much easier that is to see. But. Now you have like 15 minutes. So here are the tasks. You have that unit term test is due tomorrow. That's from last unit. This is just because I died on Friday, came back to life. We weren't here to do the review. I actually was very, very ill last Friday. With like stomach bug. Like came to work, Zoomed algebra 1, vomited over Zoom. Like couldn't get out of the building without vomiting 2 more times. It was just like I was like, I gotta go. I'm going home. So this kind of got derailed. recording, but the review is also online. It was gonna be open notes anyway, so you can use your resources. I just allowed it to be take home. Doesn't sound like many of us have gotten to it yet. It is due tomorrow, and I'd love hard copies versus online. It's so much easier to grade. So if you want to use the 15 minutes to start working on this, just know it's not this stuff that we're doing right now. It's the unit before stuff. You're gonna want unit 7 materials out if you want to look and see what's happening there. Okay? Then the homework on these special rights is not due till Monday. So if you have the time, you could start with special rights homework. If not, it'll pop up in classroom tomorrow for you to submit by Monday. Okay?